Sally pushes a 1200 Newton crate with a horizontal force of 445 newtons, a distance of 14 meters. Assume the coefficient of friction between the crate and the floor is 0.2. A. How much work is done by Sally on the crate? B. How much work is done by the floor on the crate? C. What is the net work done on the crate? I'm going to start this problem by drawing a free body diagram. So here's the crate, and label all the forces acting on it. Well, there is a gravitational force acting on the crate. The crate is on a surface. It's being pushed across the floor, so it has a normal force. The crate is being pushed, so there is an applied force. I'm going to go ahead and say it's pushed to the right. And since it is being pushed and it's on a surface, there is going to be a frictional force to the left, and it is moving, so that is a kinetic friction. Okay, so next thing we want to do is write down what we know, our givens. Okay, so the givens, well, she pushes a 1200 Newton crate. That is the gravitational force. I know it's the weight or the gravitational force because it's given to me in newtons. With a horizontal force, so this is the pushing force or the applied force of 445 newtons. And it goes a distance of 14 meters. So there we have our givens. For part, missing one. We also know the coefficient of friction, and since this is a moving crate, the coefficient of kinetic friction is 0.20. The question asks us how much work is done by Sally on the crate. So I'm going to say the work done by Sally. That is what I'm trying to find. Well, I know that to find work, I need to take the force times the distance times the cosine of the angle between the direction of movement and the force that was applied. So this is the work that Sally is doing. So I need to need the force that Sally is applying, which we called the applied force over here. Okay, multiplied by our distance times the cosine of the angle between the force and the way the crate moves. Well, the force is being applied to the right, the crate is moving to the right. So the angle between to the right and to the right is 0. The distance we wrote down was 14 meters. And the applied force that Sally is pushing with is 445 newtons. So if we go ahead and solve this, we get the work that Sally has done is 6,230 joules of work. And that is part A. Now, part B says how much work is done by the floor. Well, the floor is the surface. The surface is applying the normal force and the force of kinetic friction. So we're going to need to find both of those. Luckily, the work done by the normal force is easy. Okay? Why? Because if we look, the normal force is going up, the box is going to the right. Those are perpendicular to each other. The cosine of 90 is 0. Also, in the last video, we learned anytime the force and the direction of movement are perpendicular, the work done is 0. So there's no work done by the normal force. However, there is work done by the frictional force. So let's find that. The work done by the floor is going to be completely done by this frictional force. So we need the force of kinetic friction multiplied by the distance times the cosine of the angle. So the force of kinetic friction, we don't know that. We cannot assume it's the same as the applied force because it never said it was moving at a constant velocity. So I'm going to need to do a little bit of extra work. Okay? So over here, I'm going to go ahead and say, well, what do we know? I don't know that it's going at a constant velocity, but I do know that it's not accelerating up or down. It's moving along the floor. So I know the net force in the y direction is 0 because it's not accelerating up or down. Well, the net force in the y direction means add them up. So we've got normal force going up and we have the gravitational force going down. Substitute in. And the next thing we know, we've got our normal force is 1,200 newtons. Now, how does that help us? That doesn't give me the kinetic. Well, we've learned that the friction force is equal to the coefficient of kinetic friction multiplied by the normal force. I'm going to take the normal force, substitute it in. The coefficient of kinetic friction we were told was 0.2. And therefore we can find the force of kinetic friction, 240 newtons. Substitute that back in over here. Substitute our distance in, it's still 14 meters. The cosine of the angle. This is the angle between the direction the crate moves. The crate is going to go to the right. And the force. Well, this angle is 180 degrees. So 180 degrees. So the work that the floor does is equal to negative 3,360 joules. Now part C asks us, what is the net work done on the crate? Okay, well part C, the net work. That means I need to add up all the work done by each force. So the work done by the normal force, the work done by the applied force, which was Sally, the work done by the gravitational force, and the work done by the kinetic friction. Well, the work that was done by the normal force and the gravitational force are both zero because they are perpendicular to the direction of movement. So in reality, all I need to do is take the work done by the applied force, which was Sally, 6,230, and add that to the work that was done by the kinetic friction or the floor in total, which is negative 3,360 joules. I add those two together, keeping in mind that this one is negative, and I get that the net work done was 2,870 joules.